Hi, ladies and gents. So today's lesson is now on solving logs. So last week, remember, you went through log form and being able to evaluate logs, find out what the values are. And it does seem like some people were struggling a little bit, so I gave fewer problems for these, hopefully help out a little bit. All right, so let me walk you through a couple of these. There's really two different types you're going to see for this lesson. There's one more type you'll see a little bit later on. But these are actually pretty straightforward as long as you don't get caught up with the log jargon. And by that, just the log form of it. I know it's a weird kind of language, but the logs in here really are not that bad. So first thing, take a look at number 1 here. You've got log base 11 of negative 5x minus 5. Right, that's equal to log base 11 of negative 3x. As long as these log bases match, and there's only one log on both sides, they cancel. Right, so this cancels out, and you're left with a simple equation you can solve. Right, if I have this, I want to get my x's together. Let's see, I'd add my 5x over this way to keep it positive. Right, so I'll bring my 5x. Right, so if I add 5x over here, right, you're left with negative 5. Right, from the left side is going to equal the right side, which is now 2x. Look at that. Your logs are gone. The equation is simple, and you solve it. So it seems like it's pretty daunting at first, but it's really not that bad. So go through and solve, divide by 2. Negative 5 over 2 is, hey, that's option D. So the key is if you have logs, one single log on both sides, with the same bases, they will cancel. All right? So same thing down here, log base 16, log base 16. Cancel them. There's one on both sides, so you have a simple equation and solve that equation and find your solution. And now notice some of these no solutions may come up if, by chance, the answer that you get, say this answer, negative 5 halves, when you plug it back in, if it gives you a negative number inside here, that's not possible. Right? Because this is saying a base number to some power gives you a negative number, which is not possible for logs. So if you get an answer and plug it back into these parentheses, and it gives you a negative inside those parentheses, it is not possible, so it would be no solution. So just check for that. That comes up every now and then. So it's not possible for a log to have in that parentheses a negative value. Yeah, I'll go down and show you one more and let you do the rest of these. So the difference on this section from here to the bottom, notice, right? In here, there's logs only on one side. There's logs on both sides. So there's a way you have to treat these because the other ones only work if you have one log on each side. So let's do number 5. Notice the bases are the same, and you've got a minus in between. So since there's no log on this side, you're going to have to do something with combining these. Remember condensing? Here it is. If you condense a same base minus something with the same base, that's division. Right, so this is really log base 7. Right, put your base down there, of 4x divided by 6. Right, because division in log form is going to be minus. Right, so you can do that. That's going to be equal to 1. Right, so combine it. And now, if there was a log on both sides in the same base, you could cancel them, but there's not. So what you have to do here is this. There's this interesting property called exponentiating, which really is an inverse log. So to get rid of this log base 7, if I got rid of that, you could solve this pretty easily. So the way to do that is to make this entire thing here a power. So what we're going to do, I know it's going to look kind of funny, is take this, do 7, and make this whole thing a power. So it's really 7 to this whole power. All right, and you can do the same thing on this side. Do 7 to this power. So this is now 7 to the log base 7 of 4x over 6 equals 7 to the first power. And the reason why you do this exponentiating is, look, 7 to the log base 7 cancels. And this you can simplify. So now we really have 4x, right, over 6 equals 1/7. Or sorry, 7, not 1/7. So when you have this, now you can solve it. So of course, one of the nice tricks is to put this over once, and now we can cross multiply. So really you get 4x equals 42. Right, and then we're going to solve this guy. So divide by 4. We should come up with a nice answer. Right? 42 over 4 is not part of our solution because, don't forget, reduce, 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 reduce. So that really works out to be 21, right, divisible by 2 over 2. So that 21 over 2 is your answer for D. So this exponentiating thing is a real nice property when you don't have logs on both sides. Right? Like number 7, like number 6, like number 9, like number 10. Right? So those are a little bit different because you have no log on the one side. So you must exponentiate. Well, I'm going to do this number 8 as well for you. So number 8, well, I'll set up most of it. For this, you see multiple logs on the left side and a log on the right. So we will be able to cancel at some point, but not yet, because if you have multiple logs, you must condense. All right, so minus is going to mean we have to do that condensing part with division. All right, so this becomes log base 3, and it becomes 5 divided by x minus 4. All right, so, don't do that. 5, come on, computer. Over x minus 4. The hardest part about this is actually just writing it out on the computer. Equals, hang on. All right, sorry about that, and I'm back. So here again is the completion of the first step. So condensing the left side, 5 divided by x minus 4, because you're condensing. Right, multiple logs on one side, you must condense, which is that, equal to log base 3 of 21. All right, so we got that first step. Now look, log base 3 and log base 3. Like I did, I'll just scroll back up for a second. Like that first one, you can cancel logs now, right? So if I go back and cancel these logs, then you can solve it from there. And I'll leave you to that point. Oops. Well, you get the point. So erase that by mistake. But that log that was here will cancel with this log. So now you're left to solve 5 over x minus 4. Right, is equal to 21. And just as a reminder on this, when you go to do that, like the previous one, you can cross multiply. So you cross multiply that and work that out, and your answer will be there. All right? So this is how these logs work. So you can do the first part. If you have logs, one single log on both sides, and they're the same base, you can cancel them. So cancel, cancel, solve. If you do not have that set up, you may have to condense logs, and if there's not a log on both sides, you may have to exponentiate. And again, whatever that base number is what you use as this base. All right? So you can do that to exponentiate. So if this is log base 5, you do 5 to that power. If this is log base 8, you do 8 to that power. All right? This problem did not involve exponentiating because you had logs on both sides. There was a log here and a log here. So it really depends on the situation you're given. All right? So try these out, do the best you can, and I will talk to you soon. Let me know if you have any questions. Thanks, guys.